Now today's topic is buzzwords in instrumentation, but I'm going to speak something general also. I thought students will be there, so I'll talk something to them other than only instrumentation. So the way I'm going to cover this talk is, first I'll tell you what is instrumentation, then what are the driving forces in next 20 years for which all engineers, students should be prepared. What are the aspirations from future engineers? And then what are the 3 C's which are affecting the pace and phase of instrumentation? And finally, the buzzwords in instrumentation. So first, the very general definition of instrumentation is that it is the art and science of measurement and control. That is the most basic definition. So it is both art also as well as science. This is a very famous quote of Lord Kelvin, which you will find in almost every book on measurements. It says that when you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, you cannot express it in numbers, your knowledge is meager and unsatisfactory kind. So this is the same Lord Kelvin who invented your Kelvin scale, the temperature scale. So he has given so much importance to that the knowledge has to be quantified also. You cannot say that today it is very hot, it is very humid. As an engineer, you have to specify how many degrees centigrades, what percentage of humidity. So you should put your knowledge in quantitative terms also. So he gave a lot of importance to measurement, which is a quantitative comparison, which is expressing your knowledge in quantitative way. But you know that in our life, it is not that everything can be measured. In fact, the things which matter most to us, like our peace of mind, that you cannot measure. There is no scale for that. And then our emotions, feelings, how much love you feel for others, in fact, how much jealous you also are. These things you cannot put in numbers. So again, I'll share you one quote which Einstein always kept on his table, which is very meaningful in fact, which says that not everything that counts can be counted, and not everything that can be counted counts in life. So this also one should always remember. And then about control. See, one part is measurement part. I've already explained you what measurement and what is the importance and what is where it is not important also. That also you should know. Similarly for control, there is an old adage that if you do not know where you are going, any path will do. Suppose you don't know also where you are going, so how does it matter what path you have taken? So if you want to go to a particular place, you should know your destination, you should know your aim. Then only you can plan your activity accordingly and go. Similarly, Abraham Lincoln has said that if you would first know where we are and whether we are going, we would better judge what to do and how to do it. Then Glasgow also said, in life, as in football, you won't go far unless you know where the goalposts are. So this is about the control part. Then another thing is that instrumentation is both multidisciplinary as well as interdisciplinary. So it takes concepts and ideas from all sciences and engineering. So that is the basic nature of instrumentation. That many disciplines you will be using, you have to know the concepts of physics, chemistry, bio, all engineerings also, mechanical, chemical, and then you will be making instruments. So it's an interdisciplinary as well as multidisciplinary. Now, where do we use the instruments that we are using? You can in fact categorize them in 3 kind of broad applications. All of you must be using Doiblin's book at least, I think. That's a Bible for instrumentation engineers. I hope all of you are using. Now the new edition has come. What is that new edition now? With a professor of IIT Bombay, that Manik also is there. No? So that new edition has come. Otherwise, but previous edition contains more. This is an abridged edition, which is more like more examples are there, some numericals are there. But Doiblin is one book which every instrumentation engineer should keep with oneself. It is a Bible sort of thing. So there also the first chapter itself that says that all the measuring applications you can put in 3 broad categories. That is monitoring, control, and experimental engineering analysis. So we can put it in this form, like for observation, for control, and for understanding the physical universe. So basically these are the 3 purposes for which we use instruments. to observe. Simple, your manometers are, anemometers are there, your ECGs are there, isn't it? EEG is there, blood pressure meter is there. So these all simply monitor. Then all the instruments which are used in automation, they are a measurement devices, but they are a part of the feedback loop. So there they are used for control purposes. Then for experimental engineering analysis, because basically any problem you can approach in two ways, either a theoretical way, or then there is a theoretical analysis, then there is an experimental analysis. And for experimental analysis you need instruments. And I think we all know that how much important experimentation is. Nowadays so much simulation tools have come, very fast speed computers have come. So we first go for simulation, and then your test is not complete unless you prove it. But of course the experimentation becomes so costly and elaborate, so it is suggested that first you go for simulation. So an intelligent mix between experimental and theoretical, that is the, you can say, hallmark of a good engineer, that where we should stop theoretical and where we should go for experimental. Again, Einstein again has said that you can simply disprove a theory if you can single show one experiment which can disprove that. He says no experimentation can prove a law, but a single experimentation can disprove a law. That's right. So that is the importance of instrumentation. What is the total cost of the plant and what is the cost of instrumentation? So that is steadily increasing over the past years. You can say in 50s it was only 1 to 2%. Then in 60s it became 4 to 6%. In 70s it was 6 to 8%. 80s it was 10 to 15%. And in 2000 it has reached almost 1/4 of the total cost of the plant. Because nowadays you think of DCS, SCADA systems, PLCs. So they all, if you combine all of them, that contribute to almost 1/4 of the total cost. So that is the importance of instrumentation. Now engineering is basically understanding and controlling materials and forces of nature. For what purpose? For the benefit of humankind. In fact, not only for humankind, we should say, for all living, non-living, everything, especially all the creatures, all living creatures, we can say. It's not only we take care of ourselves also, we should take care of bird, animals, everybody we should take care of. So basically, any engineering is, the hallmark is creativity. So for like any other engineering, instrumentation is also creativity, but creativity has to be constrained by certain factors. And those factors are the cost part you have to take care, the safety part, then the environmental impact that it has, then the ergonomics, the human-machine interface, then the reliability, then manufacturability, maintainability. So it is creativity but constrained by these factors. Any engineering is like that only, similar is the instrumentation engineering. Now demand of industry these days is that you want maximum throughput at minimum cost. That is the demand of the industry. And of course you have to abide by very stringent safety, environmental regulations and the quality standards. These are the demands that are there at present of any industry. Then if you use instrumentation in an optimal way, you will find that it will give you higher product quality and yield also. I mean, quantity as well as quality, both will improve, yield as well as quality. Then you can comply with the regulatory bodies, whatever they, especially nowadays the safety and environmental have become very, very stringent, and they need to be also. I think we should place the foremost importance also to them. Then reproducibility means the same quality you are getting. Then better utilization of all the resources, like you have energy, raw material, even human resources. So this is what results by optimal use of instrumentation. Other things that are there are that you have improved plant information management. You can know everything about what is happening in the plant. You can manage the information very well. That's the meaning of that. Then plant availability means breakdowns will be less. So you have improved plant availability. And of course, operation and maintenance cost also will go down. Human drudgery, otherwise human beings are supposed to do the repeated menial kind of tasks. No? They become very quite boring. So now they are being taken care of by instruments. And of course, there are hazardous areas like deep sea, mining, or areas where radioactive radiations are there. So their instruments will be there. So human beings will not be exposed to them. Isn't it? So we can say that essence of all engineering is service. You should be professional, creative, and you should have that passion for solving the problems. Any problem comes, you should come forward with the design, the analysis part. So these are the four, you can say, essential parts of engineering: service, professionalism, creativity, and problem solving. Now here is a person, Albert Schweitzer. Maybe many of you have know about him, that he won Nobel Peace Prize in 1952. He was a theologist also, a philosopher also, in fact a very good organist also, very good musician also, and a doctor. And above all, he was a humanitarian. He spent all his life, he was from French origin, but he spent almost all after his adult life, he went around the age of 20-25, so he went to Africa and he established hospitals there, especially for leprosy patients. He worked a lot. So all his life he spent almost in Africa only. And in one of the valedictory, like when the convocation kind of things are held, so he went to a university, he was invited there, and he said something which is, I think, is very something very pertinent we should keep in mind. He said that I don't know what your destiny will be, but one thing I do know: the only ones among you who will be really happy are those who have sought and found how to serve. So that's the most important thing, that do you do everything with the feeling of service? Then only you can be truly happy. Then, as I was telling you, that as students, I want to tell you that what are the driving forces in next 20 years and how you have to be prepared for them. So the next driving forces in next 20 years will be, first thing is science, technology, and society nexus. You have to, whatever science and technology you are using, in perspective of society you have to do it. Now the thing is technology for masses. That is what the, you can say the keyword nowadays is, that you use in science and technology for masses. It should be used for society. Then convergence of technologies. And what are these technologies? In next 20 years, it will be only bioengineering, ICT, and miniaturization. These are the three driving forces will be there. You can see that nowadays, in fact, everything is around natural engineering. You are making batteries also out of glucose, carbohydrate only. Everything is becoming green only. It's all bio-based only. And then the effect of information and communication technology you are witnessing only. And the next is miniaturization. We are making things smaller and smaller only. So these are the three very important technologies which are going to rule our future endeavors. Second is globalization of industry and engineering practices. Then the employment shift also is, it is shifting from large to small entrepreneur activities. Entrepreneurship is becoming a very, very important activity. In fact, in every good institutions, university, there is a entrepreneurship leadership cell is there, a different cell is there. And at least in BITS, I am noticing that many students are going for this entrepreneur activities. They organize these kind of contests, they show the designs that they have made and then how to take it to the market. So entrepreneurship is going to be a very big activity. Then also we are seeing that employment share is more into finances, investment, banks. There more employment is nowadays going. So employment is non-traditional, less technical engineering fields that is there, like management, finance, policy planning. In fact, I have seen that most of our very bright students, they are either going for MBA after B or they are going to finance. Finance is becoming very important. They are going to investment banks. Isn't it? Then diminishing half-life of engineering knowledge. Whatever we know, it becomes sort of so less after a few years. The knowledge is expanding at such a fast rate that our knowledge is too meager, it seems, after a very small time. Then of course we require sustainability requirement in face of population growth, industrialization and environmental degradation. So you require to make technologies which are sustainable, which can face these things. Then what are the aspirations from future engineers? Now in these contexts, how you should prepare yourself to face these things. So first thing is, the future engineers, they require blend of three things, which is knowledge, skills and attitudes. These three things you have to combine in yourself. Remember always, knowledge, skills and attitudes. What is knowledge? Knowledge is know-how of facts and understanding, both the things. So first thing is, you have the knowledge of the facts, and then you also have understanding of the physical world where you are living, how it is related. Your concept should be very clear. Then what are the skills you require? You require both technical skills, and nowadays soft skills are gaining a lot of importance along with technical skills. So like technical skills, what are the things? Like computation. All of you should be very good in use of computers, software packages. Then experimentation also. Don't just love sitting in front of PCs only. Work with your hands, design things, make circuits, test them. Don't only simulate the things. Isn't it? So experimentation is also very important. Then the two activities of engineering: analysis and synthesis. You have made a system, analyze it, and you should be able to design also, synthesize as well as design. Then you should be able to evaluate it also, how good it is. Isn't it? Then soft skills are, three important soft skills are communication skills, leaderships and teamwork. Then comes attitudes. This is very, very important. Like attitudes should be positive and they should be service oriented. They are the sort of propellant for you. If you don't have them, very soon you will get exhausted. You will feel there is no purpose, drained out you will feel. So positive attitudes is very, very important, because if you have negative thinking, they are like weights only that hold you down. They will never let you go up. Isn't it? For in attitudes, I'll share with you this this Viktor Frankl. You should read this book, Man's Search for Meaning. He spent lot of his time in concentration camps, in Nazis camps. And he wrote this book. It's a very beautiful book, that how people's psychology change, how good people are there. Even in Nazis, those who were torturing them, there also there were good people. And the prisoners also, they were bad also. It was not that all prisoners were good and they were only bad. And I love this quotation of his, that what he has said is that everything can be taken from a man, but the last of the human freedom is to choose one's attitude in any given set of circumstances, to choose one's own way. This is what he concluded by living so many years in concentration camps, that it is your attitude really which determines your altitude. So circumstances could be anything, but it is your disposition toward them that is more important in life. And this also is a very good quote from Seneca, who is a Roman philosopher. He says that it is not because things are difficult that we do not dare. It is because we do not dare that they become difficult. So this is the important role that attitudes play. Then what are the abilities and traits that are required from you people? One thing is, you should have very strong analytical skills. Very strong analytical and logical abilities you should develop. Then you should be able to design and test a system, any process, any component. You should be able to design also and then test it. Then engage in lifelong learning. Don't think that you have done from here your ME or something, so it's all end of learning. You have to keep learning, because it's continuously things are changing. So change is the only changeless thing in this universe. So you have to keep yourself upgraded. Then accommodate innovative developments from other fields of science and engineering. You have to take concepts and ideas. As instrumentation engineer, it is very, very important also. So take innovative developments which are taking in other fields and incorporate them. and act as global citizens. So, but always think that it is globally things are becoming very challenging, but you have to act locally. Word will not give you all global things are happening, but you see in your things how you can use local material, local people, and then find the solution. Then value and follow professional ethics. Very important that keep your values, honesty, integrity, these are very important. Then effective communication skills, and of course creativity, professionalism and leadership. So I think after this now I'll go for instrumentation part. So what are the 3 C's which are affecting the pace and the face of instrumentation? Can you think of anything? What are the 3 C's?
Communication, creativity.
Communication,
Creativity, competence.
And competence. These are of course some soft skills also have come here.
Yeah.
I want that only technical 3 things. So, but communication is of course one of the C's. That's perfectly right. Computations is there, computers are there, communications are there, and third is the cross fertilization of technologies. So these are the 3 C's which are affecting the face and the pace of instrumentation: computers, communication, and cross fertilization of technologies. Now if you see the history of instrumentation, what is instrumentation doing is it is always taking leverage from other branches, like what others are doing, like other disciplines, whatever happens. If you take an example, like previously the clock was there, the jewel bearing was used. So that was used to make analog instruments. You have analog indicating instruments, there you are using that movement there. Then in radios you had variable capacitor, variable resistors, then vacuum tubes were there. So they were used to make first electronic instruments. Then TV came. So TV technologies were used to make CROs, spectrum analyzer, and then came PCs, and you used PCs for making virtual instruments. So you are always leveraging the technologies which are there in other fields and then making instruments. So this is just like jewel movement of the clock. It was first used to make analog meters. Then variable capacitors, variable resistor and vacuum tube from radios were used to build the first electronic instruments. Then display technologies from the television were used to make modern oscilloscopes, analyzers. And then came very high performance computation and display capabilities of PCs, and ever decreasing. Performance is increasing, the price is decreasing. And they were used to make virtual instruments. And now the latest is VENTS, which is virtual integrated network sensors, isn't it? Those network sensors, wireless network sensors. This is the latest in instrumentation. And what is they leveraging upon? They are leveraging upon the wireless technology and the MEMS technology. These are the 2 things. We all know that computers and communications, they have increased our productivity, product quality, efficiency, also offered lot of flexibility, and safety aspects have also improved. But we should remember the importance of instrumentation. Of course, computers and communication, we are using them to make it more, our instruments more effective, more efficient. But the basic thing is, see this in this real world, you are using computers to interface with this real world. So the most important things are sensors and actuators, which give information to computers and then which take information from computers to act on the real world. So from real world you are taking signals through sensors, and from the computer you are giving signals to the real world through actuators. So these are the most important components. You should not forget that. In fact, the quality of measurement, the quality of control, it will depend upon the quality of measurement and the quality of actuation you are able to give. So the most critical component or element of processes in terms of technical or economic factors is not the computer, but components which are external to computers, like sensors and actuators. Because quality of control can be no better than the quality of measurement. I am controlling the temperature of this room, I have a sensor. If my sensor doesn't give me correct value, how can I expect to get good control over here? Isn't it? So the quality of control is very much dependent upon the quality of measurement. So, accurate measurement and actuation is vital to any efficient operation of any process, and the quality of control is dependent on the quality of measurement. Thank you.